Alright, today we are just going to do a little bit more practice with multiple transformations. Okay, problems where it asks you to say like reflect and then rotate, or translate and then reflect. Okay, something like that. So we're not actually doing anything new today. Okay, we're just doing a little more practice with doing a couple of operations on the same problem. So let's take a look at this example together here. Okay, on this first one, we want to take this original triangle that's at points A, B, and C. So the first thing that we always want to do is plot those points. I'll wait until everybody's ready here. Okay, the first thing we want to do is plot those points. So A is at 3, 3. B is at 4, -2. And C is at -1, -3. Okay, so here is my original triangle. Okay, so I want to perform two operations on this triangle. First, I want to translate. Okay, so we talked about this vector notation, right? If it says translate along the vector -2, -1, that just means the same thing as take everything left 2, down 1, right? Did I? What? Oh, is it? Negative. Oh yeah, I did, didn't I? Thank you. I plotted. So -1, -3 is down here. Trying to do stuff too fast this morning. There we go. That looks a little bit better. So now I want to take that triangle and go left 2, down 1. Okay, so in terms of writing the coordinates, right, that just means subtract 2 from each x and subtract 1 from each y. In terms of the graph, it means take each point and go left 2, down 1. Right? So the point 3, 3 will become 1, 2. Right? Because I'm subtracting 2 from the x, subtracting 1 from the y. The point 4, -2 will go to 2. 4 minus 2 is 2. -2 minus 1 is -3. Then C will go -1 minus 2 is -3. -3 minus 1 is -4. So on the graph, okay, I'm going left 2, down 1 for each of these points. Now, when we have multiple things on a graph, okay, especially now, we're going to end up with 3 different triangles on the graph. We need to make sure that we're labeling our points. Okay, that's very important. So A prime will be here, B prime, left 2, down 1 will be here, and C prime, left 2, down 1 will be here. So this is what my triangle looks like, shifted left 2, down 1. So now it's asking us to take that triangle and reflect it in the x-axis. Okay. So the x-axis is right here. Right? So when I take this triangle and reflect it across the x-axis, it's going to be on top of itself a little bit because the line of reflection goes through the triangle. But to do this, we just want to look at each point individually and count the distance to the line of reflection. So for A prime, I want to go a distance of 1, 2 to get to that line of reflection. Well, then I'm going to go 1, 2 onto the other side. Now again, we need to make sure we're labeling these points. Otherwise, we're going to get lost. Okay, so this is now going to be a double prime because this is the second thing I've done to point A. Okay, so from A prime, to reflect that across the x-axis, I'm going to end up down here. Now if I take B and C, or B prime and C prime, they're going to end up here when I reflect across the x-axis. Right? So if I take B prime, that's a distance of 1, 2, 3. So then I go up, 1, 2, 3. B double prime will be right there.
Whatever.
What's up? So to reflect B prime across the x-axis, we just count the distance that point is from the x-axis. So 1, 2, 3. So then I go that same distance on the other side. 1, 2, 3.
We do the same for C, like
Yep, of 4. 1, 2, 3, 4. And then 1, 2, 3, 4.
what you gonna do about 8?
Well, we already did A, right? So A prime was up here. So we counted a distance of 1, 2. Then 2 on the other side would get me to there. Okay, so yes, there are a few different lines on the graph here.
Oh, you think you're so smart?
Okay, which is why it is very important to label our points to make sure that we're keeping everything straight. Okay, so these triangles ended up being on top of each other a little bit. Okay, but we took our original triangle, shifted it down and over a little bit, and then reflected it across the x-axis. Okay, so labeling the points is going to be very, very important. So we still need to fill in our final coordinates here. Okay, so
-2.
A double prime is at 1, -2.
2, 3.
B double prime is at 2, 3. And -3, 4. Yep. Okay, so these are things that we've already done. Right? We've already done each of these individual operations. We're just doing a little bit more practice, doing multiple things in one problem. Okay? Questions? Okay. How do we do? Oh, so we did that as we were going. We already graphed it. Okay. So on the bottom, we are taking this triangle, triangle XYZ, and we're performing 2 operations on it for each problem. Okay. For number 1, we want to translate along the vector 1, 2, and then reflect in the x-axis. So what does translate along 1, 2 mean? Write 1 up 2, right? Or add 1 to the x and add 2 to the y. Right? Do you guys want to see me do one more, or do we think that we can try a couple of these here? We can try a couple? Okay, so one other small thing to point out, okay, on number 2, the second operation says reflect in x equals y. Okay, that's slightly different than something we've talked about, right? So x equals y is just the same thing as the line y equals x, right? All they did was flip it across the equal sign, right? So let's take a few minutes, okay, and practice a couple of these. Okay, so we're taking our original triangle. It's got these 3 coordinates. And for number 1, translating it and then reflecting it. For number 2, again translating and then reflecting. Okay. Then on the back, we've got a few different operations. Okay, so let's take a few minutes, a little bit of